Okay, bismillah. Okay, folks, this part of the video has to be done separately. We had a little bit of technical difficulty when I was making the original video. I was meant to complete this part of the video after the students had gone home. I did do that at my own timing, but for some reason it didn't record. So I'm having to do it again. So here it goes. Okay, this particular question here, Paul has 8 cards. There's a number on each card. Paul takes a random 3 of the cards. He adds together 3 numbers on the cards to get a total T. Work out the probability that T is an odd number. Now, this particular question is quite a long-winded question. I wanted to show you in the most easiest way. So what I will be doing in the lesson, in this videos, I will be pausing the videos at different times and putting on some extra notes to save time in the video so it doesn't feel like this question's going on forever. Okay, so let's have a look. So, where's my pen? The pen. Okay, we've got orange. Now, work out the probability that T is an odd number. So, let's have a look what kind of odd numbers we can make. So, we can have a 2, add a 3. So, this 2, add this 3, add a 4. So, 2 add 3 add 4. That gives us a total of, that's 5. 5 add 4 is 9. So, that's an odd number. So, that's one particular total. Now you have to remember, with these 3 particular numbers, 2, 3, and 4, we can rearrange these particular numbers in 6 different ways. We have 3 numbers, we can rearrange them into 6 unique ways. And I will just quickly show you what those ways are here. So we have, for example, let's have a look what we've done. Okay, so we can have 2, 3, 4. We can have 2, 4, 3, we can have 3, 2, 4, we can have 3, 4, 2, we can have 4, 2, 3, and we can have 4, 3, 2. Okay, so there's our 6 possibilities with those 3 numbers. So when we have a 3 number addition, those 3 numbers can be rearranged in 6 different ways. So the probability of this event happening is 6. So let's write that down. So we can say here the probability of a 2 and a 3 and a 4. We have to multiply this 6 times because there's 6 different ways of it happening. That's one particular. Now let's change color here quickly and let's go to what else? What other numbers will make an odd number? So here's another one. So 2 add 4 add 5. So 2 add 4 is 6, 6 add 5 is 11. Now this, because we've got another 3-digit combination, and that can also be done in 6 ways. Let's quickly do that. And so we can have this, and the probability of a 2, a 4, and a 5, that can also be multiplied by 6. Okay, now what other numbers can we do? Right, let's have a look. Let's change color again. Let's go for this one. Nothing will use that one. Okay, blue. So we get 2, 4, 5. We can also have a probability. We can also do, let's go to that. We don't know that. We can also do a 3, 3, 5. 3 add 3 add 5. Should we add here? Pardon me, folks. So that will also give us 11. Now, because we got 2, because the 3 repeats, okay, and the 5 happens once. Now, in this particular instance, we can rearrange 3, 3, and 5. That can happen in 3 different ways. Plus the probability of a 3, and a 5. This one we're going to time by 3. But 3 different ways of getting that. At the moment, if you want to play about with those particular numbers, please by all means do so. I'll give you an example for the first one. The second one is similar. And 3, 3, 5 will be 3 unique ways. Let's move on. Okay, if you want me to, I'll just quickly do right now. So we can have 3, 3, 5. We can have 3, 5, 3. We can have 5, 3, 3. And that's really all we can. That's all different variations of getting this 3, 3, and a 5 number. So that's why we said it's time by 3. So we got 2 of them by 6, and let's have a look at another one. Okay, another color. Let's go. So we can also have now another one. We can have, we've done 3, 3, 5. We're gonna have Whoa, we can have a 3, add a 3, sorry, let's do that. 3, add a 5, and a 5. So this 3, and this 5, and this 5, for example. Okay, 3, add a 3. Oh, this is going to do let me folks, 3 and 5 and 5. So that'll give you 13. Now, because we got again, we only got 2 unique numbers, and this one's repeat, that will also only be happen 3 times. So probability of a 3 and a 5 and a 5 times that also by 3. And now let's look at the last but not least. We have another total. To get odd number, 5 add 5 add 5 will give us 15. Okay. Now that, because the numbers are all the same, will only happen once. So this is what we're looking at. So I've explained on top of here. Now we need to try to be very conservative with the space we have. We might need to move the page up a bit, but we're doing this as big as we can. Now let's look at the mathematics that goes on here. So if you don't mind, folks, I'm just going to move the page up a bit to give me a little bit more space here, because I need space. You've seen all the numbers on top. If you need to go back, please by all means go back. That's beautiful. Okay, I'm going to go a little bit up. I'm cutting out the numbers by. Okay, I'm going to try to keep it in color, folks. So let's keep it in color. Right, and let's go back to the orange. Probability of a 2. If you look over here, 2 happens once out of 8. So I'm going to use as much space as possible. 1 over 8. Once you take the first card out, you have, whoops, pardon me, folks. Once you take the first card out, okay, I don't really want to do that. You only have 7 cards left. When you take the second card out, you only have 6 cards left. This is a question without replacement. So the probability of 3, there's 2 of them. There's 2 of them. Probability of getting a 4, there's only 1 4. So we have here 1 and a 2 and a 1. Remember what we said is this thing can happen how many times? It can happen 6 times. Try to keep everything in the right order. Right, next. Green. Now we said probability of 2 and a 4 and a 5. So brackets, probability of 2 again is going to be, remember, we have out of 8, times by out of 7, times by out of 6, and then all of that times by 6. Probability of 2 is going to be 1 out of 8. Probability of a 4 is going to be 1 out of 7. Because we've taken 1 card out, we only got 7 cards left. Probability of getting a 5, it's 5 here, is going to be 4. It's 4 of them out of 6. Done. Let's quickly swap over to blue. Plus, now the probability of a 3 and a 3 and a 5. Now, remember what we said before? To keep this nice and tight. So the first one's going to be out of 8. Time by the second one is going to be out of 7, the third one is going to be out of 6. So probability of 3 is going to be 2 of them. 2, and probability of getting another 3 is going to be now 1, because we've just taken one of them out. Probability of getting a 5 is going to be 4 of them. So you can see quickly now the mathematics is coming into life in the sense of what we in this question. Okay, mathematics. Okay, here comes the next question. Right. So you have probability of a 3 and a 5 and a 5. Probability of this, so again, same format is the first one, first pick. We have 8 cards, then we have 7 cards, and then we have 6 cards. So probability of the first 3 is going to be 2 out of 8. Probability of a 5 is going to be 4 out of 7 because there's 4 of them. And then once you take one of those out, we have 3 left. Okay, we're getting towards the last one now, the probability of a 5, 5, 5. Okay, all right. So that's going to be, remember we said there, again is 8, 7, 6, because it's without replacement. Sorry folks, it's taking this long, but this is trying to find the quickest way of showing you. The first probability of 5 is going to be 4 out of 8. Then it's going to be 3 out of 7 and then 2 out of 6. And that, let me just quickly check, is that exactly what I'm supposed to be getting? Okay, lovely. Now, what we need to do, we need to start, remember this is non-calculated paper, we need to start cancelling everything down and then making fractions equivalent and simplifying, and then we finally get to the answer. Right, let's choose a color. Let's choose, for example, a red color for universal cancelling. I think the 1 is a bit thick. Let's go for 0.5 now. Here comes some crazy cancelling now. You ready for the cancelling? Here we go. So we have here, so 2, oh, I don't really want to do that. Okay. Divide that by 2. Divide that by 2. Okay, so we get that. Okay, so we got all 1s on the top and a 6 over here and a 3. We can even cancel this 3 as well. Okay. Okay. We can just leave that. So let's come this 3, divide that by 3, divide that by 3. That'll give you 2 there. Here we go. Divide that by 6, divide that by 6, divide that by 4, divide that by 4. Okay, lovely. Okay, divide that by 3, divide that by 3, divide that by 2, divide that by 2, divide that by 4, divide that by 4. Okay, next one. We have 6, sorry, divide that by 3, divide that by 3, divide that by 2, divide that by 2, divide that by 4, divide that by 4. Okay, lovely. Right, next one. We divide that, oh, I don't want to do that. Okay, divide that by 4, divide that by 4, divide that by 2, divide that by 2, divide that by 3, divide that by 3. Okay, so we should get something like this. Let's have a look what that tidies up to. So we have now 1 time by 1 time by 1. Okay, we can also do a little bit more cancelling here. Divide that by 2 and divide that by 2. So cancel until we can't cancel anymore. So 1 time by 1 time by 1 time by 1 is 1. Then you got 4 times by 7. So 4 times by 7 and 1 will give us 28. So the first one cancels down to 1 over 28. Lovely. Let's change to a, let's keep it cancelling. Let's have a look. That's all gone. That was a 1. That was a 1. Okay, that's lovely. You have 1 time by 1 time by 1 time by 1 is 1. So you have 2 times by 7. That will give us 14. Now we cancel these ones down. We have 1 time by 1 time by 1 time by 1 is again is 1 on top. We have 2 times by 7 is 14 on the bottom. That's lovely. That's coming nice. So we have 1 time by 1 time by, okay, hang on a second. We have a 3 here. Okay, well, that's fine. 1 time by 1 time by 3 time by 1 is 3. We have 2 times by 7 time by 1, which is 14. We have all 1s. Time by 1 is 1. And we have on the bottom 7 times by 2 is 14. So we have 1, 2, 3, 4, 5. Okay, all the fractions are in terms of 14s and 28s. And we can quite easily make them equivalent quite easily by multiplying these fractions by 2, top and bottom, to make them equivalent to 28s. So now we have 1 over 28 plus 2 over 28 plus 2 over 28 plus 6 over 28 plus 2 over 28. And that gives us a grand A total of, let's have a nice different color. Okay, let's go, we've done purple, you know, let's close them. I think we need to go back to red. Now, if we add up all these numbers, we have 1 add 2 is 3 now. 3 add 2 will give you 5. 5 add this is 11. 11 add the 2 is 13. So that gives us 13 over 28, and that is the final answer. Folks, I'm really sorry if this question is taking like forever, but that's kind of in the way, the easiest way I could really explain the question to you. And I'm glad I'm using my big 27-inch screen monitor for this, because it gives me a nice big working area, and I've been able to do it nice and comfortably. Thank you very much for joining us for this question. I'm going to carry on with the paper now. I've got 2 more questions to do. So apologies for taking so long, but I just wanted to explain each part to you, so you don't think also you missed out all the steps and we don't understand, we can't do it for ourselves. But here we go, question number 24. Now we got two more questions. Let's knock this paper on the head, and it's getting late and I don't want to go to bed. Okay, right, let's have a look. Where are we with my mouse? Here it is. Here we go. Here we go. Okay, lovely. Okay, question number 24. Okay, question number 24. A is the point with coordinates 1, 3. Okay, B is the point with coordinates 4, -1. The straight line L goes through both A and B. Okay, now it says, question says that is the line of the equation 2y equals 3x minus 4 perpendicular to line L. So the line L is the line that goes between these 2 points. So what we need to do first of all, in order for us to check for perpendicularity, okay, we have a test. That test is this. The gradient of the first line, so the gradient of line L, times by the gradient of the perpendicular line, which is this one here, the second one, must be equal to -1 in order for them to be one to be perpendicular to the other. That's a test that we have in mathematics. So what we need to do, we need to rearrange this equation here to work out the gradient, and we need to work out the gradient of these 2 points here. So the easiest one to do is this one here. So let's start away. Let's change the color. Let's go for orange. We have 2y is equal to 3x minus 4. Now remember, let's change again. The template is y equals mx plus c. That's our template for the equation of a straight line. Now we must have y, but we have 2y. So what we need to do, we need to divide everything by 2. So we now have y is equal to 3 over 2 x minus 4 divided by 2 is 2. So we can now clearly say that our gradient is 3 over 2. 3 over 2. Okay? That's what the line that's meant to be perpendicular. That's this one here. So we now know this. Oh, whoops. We know that one. We now need to work out the gradient of these 2 points. Now, this is x, this is y value. Now, in order for us to work out the gradient m of the line L is equal to the change in the y values divided by the change in the x. Okay, we can say it as y2 minus y1 divided by x2 minus x1. So if we take the top ones as the y2 and bottom y1, and that's x2 and x1, we can do it quite nicely and quite easily. Okay, dokie. Now, so we start with the 3. 3 minus minus 1. 3 minus minus 1. x2 is the top one. 1 minus 4. So 3 minus minus 1 becomes 3 plus 1. That becomes 4. 1 minus 4 is minus 3. We can write that better as minus 3 over 4. So we have now know this one. ML is equal to minus 3/4. And this one is 2. So let's try the test. So ML times by M perpendicular must be equal to -1 in order for this condition to be true. So ML is, we just worked it out, as minus 3/4. We times that by the perpendicular gradient, which was 3/2. So minus 3 times by 3 will give you -9. 4 times by 2 on the bottom will give you 8. So we got a number that's close to -1, but it's not actually. So this here is not equal to -1. So it's failed the test. In order for two lines to be perpendicular to each other, when you multiply their gradients, you must get -1, and we have here obviously not got -1. So our conclusion to this particular question is the line, and the answer is no. No. The with the equation 2y is equal to 3x minus 4. Another line is not perpendicular to line L. Okay, that's done. Okay, folks, hope that's explained clearly. So we got some crazy answers there. Wasn't minus 1. Okay, last question, and last but not least. Okie lovely. I'm going to try to join these videos together so you get a nice one big video when you revise. Okay, page down. Okay, I think for this one I'm going to need to zoom out a bit to make it just okay. All right. Okay, this is the last question, question number 25. The diagram shows part of the curve with equation y is equal to f of x. The coordinates of the minimum point is 3 minus 4 right now. So this is transformation of functions. Okay, if you look at some of the videos, you'll see some more work on this. Now, this is your standard function, which is this, y equals f of x. So we worked out y is equal to f of x, and then we've added 3 as an end, like a at the end, after we've done the function. So what that does, okay, every time I try to draw a curve, it just goes crazy. So I'm just gonna like to draw some points for you guys to see where the curve should be. Okay. Okay, I'm trying to put the lines so you can draw your own curve on it when you do your exam paper. So I find it very difficult to draw curves using my current physics with this like equipment I have. So it's gonna move up by 3 points. So the graph is down by minus 4, and then we're gonna add 3 to it. So what's gonna happen to the coordinates is that 3 minus 4, the x value stays the same, so we still get 3. But the minus 4, we add 3, gives you minus 1. So that's the effect of the plus 3. So I see apologies already for the roughness of this kind of dotted line, but just trying to give you an idea of what the graph way would go. So apologies that I'm just having difficulties in drawing curves using my current equipment that I have. And the software here doesn't really help me draw curves. So y is equal to f of 2x now, this one. When we put the 2 inside the function, what happens is, rather than this point being happening at x equals 3, that 2 is like it squeezes the function down. So that 3 then moves to 1.5. So we start getting the curve down here instead. So it squeezes the curve down. So now we have the point at 1.5 instead. That point moved to there. And the minus 4 stays the same. So I'll put the coordinates here. So it'd be now 1.5 minus 4. That stays exactly the same. Okay, the next question, which you can't see, I'll just quickly pop it up a bit. You can see now, for y equals f of minus x. Okay, we leave that there, that's fine. Okay, let's change that. Now, when we put the minus inside the function, normally the minus outside is a reflection in the x-axis, but a minus inside the function itself is a reflection in the y-axis. So in a sense, we can get like, this kind of effect. So this original curve here will go across the y-axis. Okay, there. So now we can have this point here. Oops. So that will be now not plus 3, but it will be minus 3. The distance down will be the same. So it will reflect across in this mirror line. So the answer for that one will be minus 3, minus 4, and that's the end of the paper, folks. I hope you have found some benefit in this particular paper in terms of your revision for examination, and this has been requested to me to be done by some of the students, some of the people following our channel on YouTube. If you found this video beneficial, please forward the link on to your friends who can also benefit from the examination preparation. If you find any mistakes in there, please drop me a polite message and I will try my best to look at it and edit it if possible and to correct it. Thank you very much for viewing. Please give us some feedback on how this examination paper has helped you with your examination grade. It would be lovely to hear from my YouTubers. Thank you very much, and that's the end of this video, and inshallah we'll see you in the next video. Until then, okay, let me stop this. Where's the stop button gone? Okay.